Hi guys, this is our last section we're doing. So today we're going to evaluate inverse trig functions. The inverse of a trig function is used to find the measure of an angle. So that's what we're going to be looking for. We're looking for angles. Our answers are going to come out to be pi over 3, 2 pi over 3, 5 pi over 6, those kind of answers. So we're going to have to look at what's given here. We're going to be looking for theta. Theta is just an angle. And telling you here that sine of theta is 1/2. So, and I'm going to be looking in the second quadrant, so in quadrant 2. So the order that you do this doesn't really matter if you want. What I would maybe suggest is drawing your triangle in the correct quadrant. So since we're in quadrant 2, I know pi over 2 is up here, pi is over here, so that's what puts me in the second quadrant. Remember, the triangle always has to touch the x-axis. And then here's the reference angle that we're going to be looking for. Sine of theta is 1/2. So remember, sine means the y value. And if the y value is equal to 1/2, this side of the triangle is 1/2. If I was looking at those ordered pairs, if the y value is 1/2, so it would be the second one here, this is the 1/2. That 1/2, we should tell you, if you want the 1 to be on the right side, that would give us a 30-degree angle. 30 degrees is the same as pi over 6. So if you wanted to fill in the x, just, for practice, that would be negative radical 3 over 2 because it's going to the left. The y is positive because it's going up. So we've got our reference angle, but I actually want an angle that is in the second quadrant. Remember, every angle always starts here, and it's going to go all the way over to here. So it's not going to quite make it to pi. Now, since we're dealing with pi over 6 as being a reference angle, I'm going to go ahead and change this to 6 pi over 6. So it doesn't quite make it there. It's a little bit smaller. So to get my theta, I'm going to do 6 pi over 6 minus pi over 6. And the angle for this answer is 5 pi over 6. All right, let's try another one. So this time we've got secant. Remember, secant is one of those that we're not quite, as comfortable with. So what I like to do here is change this to cosine. So the reciprocal of secant is cosine. So now I know cosine means my x value. So it'll be a little bit easier to deal with. Now, if secant was negative radical 2, so that's over 1. If I flip that, cosine would be negative 1 over radical 2. Now that's not one of those numbers from the unit circle, which if you look down at the bottom here, we'll fill this out here in a minute, or you can go and get one of your old ones from your other notes, because that does help. This is not one of the numbers that comes from there. So remember, you can't have a radical in the denominator. So if you multiply the top and the bottom by radical 2, this tells me negative radical 2 over 2. So my x value is going to have to be negative radical 2 over 2. It tells us which quadrant to work with. So this is between pi and 3 pi over 2. So if I start to practice, pi is always right here, and then this is 3 pi over 2. So that puts us in quadrant 3. Remember, when you make that triangle, make sure that it's always touching that x-axis. Don't ever let it touch the y-axis. All right, the x value. So the x value is going to the left, so it's negative radical 2 over 2. The y value would be the same. You're only going to have radical 2 over 2 when you have both of them being the same. If you like to write that ordered pair, that's negative radical 2 over 2, negative radical 2 over 2. That's going to give me a 45-degree angle, or pi over 4. Now, since this is over 4, I'm going to change this pi to 4 pi over 4. The angle is really going all the way past. It's going past 4 pi over 4, so my answer is going to be bigger than that. So to get my angle, I'm going to do 4 pi over 4 plus that reference angle, which was pi over 4, to give me an answer of 5 pi over 4. So the angle in that third quadrant is 5 pi over 4, and secant of theta is negative square root of 2. All right, let's try tangent. Tangent gets a little bit tricky sometimes. So remember, tangent means sine over cosine, which really means y over x. So I need to have a pair of numbers that are going to simplify to give me radical 3. So if I use these radical 2 over 2's, it's never going to give me the radical 3. But if I use one of the pairs that has a radical 3 in it, I'm going to get there. So if I put the radical 3 over 2 on top over 1/2. So I've got radical 3 over 2 over 1/2. So I know my signs aren't correct because one of them is going to have to be negative, but when I draw it in the quadrant, that should help. But I know that my y value is going to be radical 3 over 2, and then the x value will be 1/2. This is telling me to draw the triangle between 3 pi over 2 and 2 pi. So remember 3 pi over 2, this is always pi over here. Here's 3 pi over 2, and then here's 2 pi, which means that my triangle is going to be in this fourth quadrant. So I'm in quadrant 4. Move that up a little bit, sorry. And now I'm going to label. So it said the y value. The y is the one that goes down here. So that's radical 3 over 2. Since it's going down, it's negative. The x value is this side here, so that's 1/2. If you want to write it as an ordered pair, you can. But what we have to get from this is we have to get the reference angle. So if I know, if I've got my hand here, if I want it to be 1/2, that's going to give me a 60-degree angle, or pi over 3. So I always try to remember too, whenever there's a 1/2, 30 is always across from the 1/2, 60 is always across from the radical 3 over 2. Just, 30 is half of 60. It's kind of a trick I use to remember it, but all right. So now what we need, we've got a reference angle is pi over 3, but I want to go all the way, I want to almost get to 2 pi. So since I'm dealing with a pi over 3, I want to change 2 pi to be a fraction over 3. So 6 over 3 is the same as 2 pi. It's not going to quite make it there, so I've got to do 6 pi over 3 minus pi over 3 gives me 5 pi over 3. All right, let's go ahead and fill in this bottom part here. So the steps to solving trig functions, first would be to isolate the term. Okay, no, I know we already had the term isolated up here. The problems you're going to see next will not be like that. So we're going to have to do a little bit of algebra first. So this is an algebra step. We're going to isolate the trig term, get sine, cosine, or tangent by itself, find the reference angle from the unit circle, which is what we were just doing, and find the possible angles based on the sign. So we're going to get more than one answer here. So a couple things to remember here. Here is that first quadrant. This is the ordered pair. It goes over 1, up 0. This is the ordered pair. It goes over 0, up 1. And you can use your hand if you want to. This ordered pair right here is going to go over radical 3 over 2, up 1/2. This is our radical 2 over 2, radical 2 over 2. And then this one goes over 1/2, up radical 3 over 2. So right here, I've got this is a 30-degree angle, or that would be pi over 6. This would be my 45-degree angle with the radical 2 over 2, or pi over 4. Here's my 60-degree angle, or that would be pi over 3. The denominator is never the same as the degree angle, if that kind of helps. This is a 0-degree angle right here, or if you went all the way around, it would be 2 pi. And then this is pi over 2, or 90 degrees. That's one of those quadrantal angles. All right. Then, this is just to kind of help you remember your signs. Here, my x is positive and my y is positive. It goes over and up. Here, my x value would be negative and my y value would be positive. In this third quadrant, they're both negative. It goes left and down. And then in the fourth quadrant, it goes over and then down. So we're going to kind of put all this together and solve for some angles.